As far as market structure goes, we've talked about perfect competition and monopoly. These represent two extremes of the spectrum, one where there's many providers of a product and one where there's only one. In reality, the real world is not really like either of those. Typically, you're going to have a handful of firms providing a product. And that situation is what we call oligopoly. And formally, an oligopoly is going to be a market structure where there's only a few sellers that offer identical products. Good examples of this are things like credit cards. There's only a few major issuers of credit cards. There's Visa, MasterCard, and American Express, and there's not really any others. Cell phone providers is another good example. You have Verizon, AT&T, T-Mobile, Sprint, and they make up the majority of cell phone service providers. And the focus when you study oligopoly typically is in their strategic behavior. And specifically, we want to recognize that in an oligopoly, any firm's decision about price or quantity produced can affect the other firms in that market and cause them to react. And each firm is going to consider other firms' reaction when they make their own decision. And to analyze firms in an oligopoly and look at their strategic behavior, we're going to have to introduce some game theory. And game theory might be a term you've heard before, but basically it's used to describe the study of how people behave when they're in strategic situations. So let's look at an example of two cell phone providers in a small town. Again, we have two providers. And just a note, if you have two providers of a good, we have a special name for that, which is duopoly, which is just a oligopoly with two firms instead of a handful. And let's say our providers are AT&T and Verizon, and they're competing for customers in this small town, and they both faced the same costs. They have fixed costs of $0 and a marginal cost of $10. And then our chart over here, our table, shows us the demand schedule for the town. So at a price of $0, the quantity is 140. We're going to assume this is the number of residents, since at $0, everyone should want this. And then as price increases, fewer and fewer residents of this town demand cell phone service. So first, let's calculate a few things. We want to calculate revenue, the cost, and the profit at each of these levels. So we have $0 revenue at $0 price, and our costs are $10 per resident, so $1,400, and profit is negative $1,400. At a price of $5 and 130 residents, we have revenue of $650 and cost of $1,300 with a profit of $650, and we can continue this for the whole table. So first, before we consider the duopoly outcome, let's consider the past market structures we've looked at. We know if we're in a competitive equilibrium or perfectly competitive market, and there's free entry and exit, firms are going to enter and compete and drive profits down to $0. That's going to be this outcome here. On the other hand, if we have a monopoly and we have one seller, they're going to extract as much consumer surplus out of the market as they can, which means they're going to have the highest possible profit, which is going to be this outcome. So this is the monopoly outcome. So the duopoly, Verizon and AT&T, they would also like to extract the most consumer surplus they can out of the market. They would like to provide 60 residents with cell phone service at $40 for the price, because that gives the highest total profit. But then the question is how to split this among the two providers. So what we just described is one duopoly outcome, which is going to be collusion. And collusion is simply an agreement between the two firms about the quantity to produce and the price to charge. So one solution is AT&T and Verizon decide to split everything evenly in that case, each firm is going to produce 30 out of the 60 units that they're targeting, and they're both going to charge the same price of $40, and that means each firm's going to get a profit of $900. However, now we want to look at what happens if one of these firms deviates from their agreed upon production schedule. So let's say AT&T does not honor this agreement, and they decide they're going to produce 40 units instead of the agreed upon 30. And Verizon's still going to produce the 30, and so that means the market quantity of the market is going to be 70, and the market price is going to be 35. So that means AT&T is going to have profits of their marginal revenue, which is 35, minus their marginal cost, which was 10. Remember, 10 we established on a previous slide, and they're going to produce 40 units, which is $1,000. And Verizon is still going to produce the agreed upon 30, so their profit is going to be marginal revenue minus marginal cost times their units, which is going to be 800. So obviously, as an individual, AT&T has an incentive to deviate from their agreement. AT&T can increase its profits. However, if both firms decide to deviate, they both decide to produce 40, that means the total quantity is going to be 80 at a price of 30, should be here, which means they would generate 1,600 in profit split between the two of them, or they both have 800. If they both deviate, they're worse off than if they had stuck to their agreement. So the point is that as a whole, as a industry, they're better off colluding, but if they're self-interested, each one has an incentive to deviate and hope the other doesn't. So what we just described is a classic case of the prisoner's dilemma, which may be something you have heard of before. And the prisoner's dilemma is a canonical game theory situation that describes two prisoners. In this case, it's Bonnie and Clyde. And they are being interrogated after they've been caught, and they can either confess to their crimes or remain silent. And so this matrix represents all the possible outcomes that could occur. Clyde could confess or remain silent, and Bonnie could confess or remain silent. And their prison sentence is going to differ based on if they confess or remain silent. So if they both confess, they're each going to get 8 years. So orange here is Clyde's sentence and 8 is Bonnie's. If they both remain silent and don't admit to anything, they're both going to get 1 year. However, if Clyde is silent, but Bonnie confesses, Clyde's going to get a much more severe punishment, 20 years, whereas Bonnie gets off free. And the reverse is going to be true if Bonnie remains silent, but Clyde confesses. So if we're looking at this as a socially optimal outcome, obviously they should both remain silent. That minimizes the number of years served in jail as a group. So to analyze their decisions, we can pick the side of a character and look at what they would do relative to what the other person is going to do. So let's say we're Clyde, and let's assume Bonnie is going to confess. Well, now he can either stay silent and get 20 years or confess and get 8 years. Obviously, he's going to confess if he knows Bonnie's going to confess. So we'll put a little underline here. That's what he would prefer to do in the case Bonnie confesses. If Bonnie remains silent, we can do the same thing. We can say he can either also stay silent and spend 1 year in jail, or if he confesses, he doesn't spend any years in jail. So obviously he would like to pick confess in this case, assuming he's willing to throw Bonnie under the bus and send her to jail. And if we do the same thing for Bonnie, we can assume Clyde confesses. Now Bonnie has a choice between 8 and 20. She's obviously going to pick 8. And if Clyde stays silent, Bonnie can either pick 1 year in jail or 0. So obviously she's going to pick 0. So you'll notice the underlying outcomes, that's the preferred outcome for each prisoner given what the other is going to do. And you'll notice that for Clyde, no matter what Bonnie does, he's better off confessing, right? All his underlined outcomes, the outcomes he prefers, are in the confess upper portion of the matrix. And for Bonnie, the same thing is true. Her underlying outcomes are 8 and 0, which are in the confess area. And so if both Bonnie and Clyde are analyzing this decision rationally, their dominant strategy is going to be to confess, even though it doesn't lead to the socially optimal outcome. So we call this, this quadrant here, put it in blue, we call this a Nash equilibrium. A Nash equilibrium is just a state of the world, or a state of decisions where no person by themselves has any incentive to deviate. So if we assume they're both confessing, if Clyde deviates and decides to pick silent, he's going to be worse off with 20 years. If Bonnie is currently confessing, they're in the confess cell. If she deviates and remains silent, she's going to get 20 years. So that's the basics of game theory. Kind of the classic first exposure you get in economics is the prisoner's dilemma, and it describes what we see with collusion among duopolies. It's difficult to achieve the optimal outcome for the duopoly or the oligopoly because their dominant strategy is to do something that is not the optimal strategy. And there is much more you can do with game theory, but we're going to leave it at that, just introduce it slightly. And that will wrap up our discussion on market structure. And that is also the last lecture of the course.